When we ask an AI a question that it doesn't already have context or knowledge about, it often tries to respond using only what it was pre-trained on. Like a student recalling fact from memory, this works fine for common questions. But when the question is new, specific, or highly detailed, the AI might give an incomplete or even incorrect answer. That's exactly where RAG or Retrieval Augmented Generation comes into play. RAG enhances the AI's ability to respond by first searching through a collection of documents, articles, or datasets to find the most relevant pieces of information and then using that retrieved context to generate an accurate, well informed answer. In our previous video, we explored semantic search, vector embeddings, and fires a vector database and learned how they make it possible to store and retrieve information efficiently based on meaning rather than just keywords. In this video, we will take it a step further and deep dive into RAG, understanding how it merges information retrieval with generative AI to deliver responsive that are not only precise but also context aware. A context aware response means the AI doesn't just produce a generic or random reply. Instead, it ensures the answer is grounded in the most relevant and reliable information available. Think of it like having a super smart assistant, one one first scans through all the necessary documents, understands that's important, and then crafts a response that's accurate, relevant, and right on target. Great. Let's first try to understand RAG at a very high level and how it actually works. Imagine you have a large collection of documents. Okay. The first step is to break these documents into smaller chunks, make them easier for AI to process and analyze. Next, for each chunk, the system creates a vector embedding, a numerical representation that captures the meaning of the text rather than just the words. These embeddings are then stored in a vector database, a specialist type of database designed for fast similarity searches. Now, when a user enters a search query or prompt, the system converts that query into its own vector embedding. So we have a query, we have converted that query first into the vector embedding. Now this query vector is then compared against all the stored vectors in the database to find the most similar ones, essentially identifying the chunks of text that are most relevant to the user's question. The database then returns the top key results, which represent the most contextually relevant piece of information. Finally, these retrieved chunks are passed to a large language model such as ChatGPT, which reads, understands, and combines this information to generate a coherent and context aware response. In short, RAG blends semantic search with the generative power of LLMs, ensuring the final answer is both accurate and relevant to the user's story. Now, let's try to understand RAG and its importance. The very first point is the accuracy. Answers are always based on real, up to date sources, not just AI memory. Second is context aware, where AI can provide answers tailored to our specific question. The third is scalability, where it can handle large amounts of information that a human or a standard AI might struggle with. Fourth, and the last is trustworthiness. Since the response comes from verified sources, we can rely on it more. Yep. Now, this is a little bit more detailed how the RAG works end to end, step by step, very detailed. Okay. Now, in the step one is to load the documents, gather all the documents or data we want our AI to learn. It can be PDFs, articles, or any text file. The step second is to load required Python libraries, import the necessary libraries that will help us process the data, such as tools for embedding, test chunking, and vector databases. Now, the step three is to chunk the documents. Chunk means divided into a small parts. Okay. For example, 500 characters or 300 characters. Now, as we know, large documents are often broken into smaller pieces called chunks. These help the AI process and understand the text more effectively. Step 4 is to create vector embeddings. Use a model like one from sentence transformers or OpenAI embeddings to convert each text chunk into number, which called as vector embeddings. These embeddings capture the meaning of the text. Now the step 5 is to store these vector embeddings into the vector database. These numerical representations are stored in a vector database such as FIS or Python, which allows for faster and efficient similarity searches. Great. Now, this part was to gather a document, different documents, and store those documents in the vector embeddings. This is done. Now we have to make a search on the stored document. So, for example, if a user search a query, okay, when a user asks a question, the query or a prompt get converts into the vector embedding. Okay, so that particular query will also get converted into the number, and number is nothing but a vector embedding. Okay, it's a right for similarity search to come in picture. Query vector with the stored vectors in the database to find the most similar or relevant piece of information, and it will return us the top k results. So whatever number we are going to pass, it will return those many results to us. Finally, large language model or LLM, these top results, they take these top results, okay, from vector database, whatever result we got for that query, understand the context and generate a final well structured answer for the user. And that's all we have for today around the RAG. Thank you so much for watching this video. If you found this video helpful or want to see more video on AI, don't forget to like and click on the notification bell icon to stay updated and subscribe to the channel. See you in the next video. Till then, bye bye.